All right, guys, here we are again. Good morning. Today's lesson is just a review on waves. We were working on waves before we left. And so the first thing we want to look at today as we look at waves is exactly what is a wave. And so here in a little bit, or hopefully you've already done your success starter, your bell ringer this morning, just talking about exactly what a wave is. So our essential questions will cover what is a wave. It will also cover, so after we look at what a wave is, how do waves travel? We'll look at what are the types of waves. I'm sure already now you're starting to remember some things. And then we'll look at what are the properties of waves. We'll also look at the 4 different interactions of waves. We're going to break this apart over a series of days. And so today we're just going to deal with what a wave is, how do waves travel, and what are the types of waves. So this says November 19th. Obviously, this was made before, but if you've gone into Google Classroom, you've seen the link for the Google form, and fill that out for me, please. And on that link, I need for you to tell me what a wave is. How does a wave travel? What are the types of waves? And what are the properties of waves? If you choose to do that bell ringer after we finish this presentation, you can always use these notes to come back in and look at it. So what are waves? What is a wave? So when we look at a wave, waves carry energy. And so that energy is a disturbance that transfers energy through matter. So if I have matter like water, if waters are matter, then the wave is going to travel the energy through that. So when we see a wave on the ocean, all that is the transferred energy. So energy that is moving through that matter, which in this case would be the wave. And so a wave, again, is any disturbance that transfers energy through matter. So when energy is transferred through matter, that is what we refer to as a wave. Waves only carry energy. They do not carry matter. So it doesn't carry matter. A wave is not necessarily matter itself. It's the energy that is carried through matter. Once the wave has moved, the disturbance is gone. So once the energy goes through the water, if you've been at the ocean and the wind was high, you'll see that the waves are created. But then once that energy from the wind goes down, we no longer see those waves. So to repeat, the definition of a wave is any disturbance that transfers energy through matter. So how do waves travel? Well, waves must have matter to travel through. They must have a medium. They must have something that they're moving through. So when we refer to the type of matter that a wave is traveling through, that is a medium. If we're referring to the air, and we get sound waves traveling through the air is our medium. When we talk about water or the ocean, the water is then the medium that energy travels through, or the matter, the medium / matter that the energy travels through that creates the wave. So just to repeat, waves travel through matter. The matter that it travels through is then referred to as the medium. As we look at waves, we also want to look at the types of waves. Excuse me for my little slip up there, moving a little too fast. So when we look at mechanical waves, we've looked at these. These are different types of mechanical waves, and these guys need a medium to travel through. These waves cannot travel. This energy cannot be transferred unless it has something to travel through. Types of mechanical waves are sound, air, water, ropes, earthquakes, and then tsunami waves. Electromagnetic waves are waves that do not need a medium to travel through. So examples of these electromagnetic waves are your X-rays, radio waves, infrared radiation. We get that from sunlight sometimes. Microwaves and visible light. These guys are electromagnetic waves. Again, the difference between a transverse wave and electromagnetic wave is that the transverse wave does not need a medium to the mechanical wave does not need a medium to travel through. The electromagnetic wave does need a medium to travel through it. Just to retract here, mechanical waves can either be transversal, and you can see that here. Mechanical waves can either be transverse or longitudinal. And electromagnetic waves are always transverse waves. So although our mechanical waves can be transverse or longitudinal, electromagnetic waves are always considered transverse waves. Again, up here we can see our types. So these are our types of electromagnetic waves. Again, these electromagnetic waves do not need a medium through which to travel. Transverse waves. So waves in which the particles vibrate in the up and down motion. So we did that with our slinky and watching Bill Nye. So if the waves travel in an up and down motion, then these are considered to be transverse waves. There is a video also that will be dropped in Google Classroom to see the movement of a transverse wave. There are some as well that have already been posted in the stream. So here's a picture of a transverse wave. Let's just review the parts. The wavelength we measure from crest to crest or from trough to trough. Wavelength is always measured from one point on the wave to the same point on the wave. The crest is the top of the wave. So here's a crest, and here's a crest, okay? The amplitude is the measure from the crest to the rest. So where the crest starts to almost where the wave begins to come to a point of rest. If we look at the trough again is the bottom or the lowest part of the wave, trough, trough, trough. And so again, these are just the parts of a transverse wave. Longitudinal waves, they are waves in which the particles vibrate back and forth along the path that the wave moves. And again, there's a link for the YouTube video, and I'll drop that as well on the direction and the way that longitudinal waves move. Here's a longitudinal wave. Again, we're looking at our wavelength. These are different. When we look at longitudinal waves, instead of being measured from crest to crest or trough to trough, we measure longitudinal waves from wavelength to wavelength. These sections where the wavelengths kind of come together are referred to as a compression, and the space in between is the rarefaction. Longitudinal waves carry the energy along the wave. And that does it for today. Those are just your notes on waves and types of waves. And so now you should know what a wave is. You should be able to tell me some types of mechanical waves. You should be able to tell me types of electromagnetic waves. And we should also be able to identify some of the parts of the wave, the crest, the trough, the amplitude, and the wavelength. Tomorrow I'll check back in with you and we will go over the properties of waves. That's our day 2 lesson. You see that posted here. We'll do that tomorrow. Please make sure to go in now and complete the assignments. You need to make sure that your bell ringer is completed. And then the questions for lesson 1 for this section. If you have trouble, please reach out to me and just drop a comment in the post. Or you can send me a private message via Google Classroom or email me. Again, my office hours are 9 a.m. to 12 p.m. each day. And we'll pick back up tomorrow with properties of waves. See you then. I hope this helped you understand a little bit better. Have a great day.